In this section, we're going to be looking at bisectors in triangles. To start off with, we're going to look at two terms, concurrent and point of concurrency. When three or more lines intersect at one point, they are concurrent. The point at which they intersect is the point of concurrency. So we're going to go ahead and look at a theorem, Theorem 5-6, which uses these two terms. The theorem is called concurrency of perpendicular bisectors theorem. The theorem states, the perpendicular bisectors of the sides of a triangle are concurrent at a point equidistant from the vertices. So here you can see in the diagram that we have the perpendicular bisectors of PY, PX, and PZ. And these perpendicular bisectors are concurrent at point P, which means they all intersect at point P. And because of this, lengths PA, PB, and PC are all equal to each other. Now we're going to look at two different terms. Here we have circumcenter and circumscribe. The point of concurrency of the perpendicular bisectors of a triangle is called the circumcenter of the triangle. So in the top diagram, here you can see that the perpendicular bisectors of the triangle are called the circumcenter. Now, if we look at the circle that's around the triangle, we can say that the circle is circumscribed about the triangle, which means it is drawn around the triangle. Now we're going to look at the circumcenter of different types of triangles. The circumcenter of an acute triangle always lies within the triangle. So if you find the perpendicular bisector of each side and extend that line, they'll intersect on the inside of the triangle. Now if you did this for a right triangle, they would intersect on the hypotenuse of the triangle. And if you did this for an obtuse triangle, they would intersect outside the triangle. So based on these three triangles and where these circumcenters intersect, you can tell whether the triangle is acute, right, or obtuse. Now we're going to be looking at two different terms. Here we have incenter of the triangle and inscribed in. The point of concurrency of the angle bisectors of a triangle is called the incenter of the triangle. So here in this diagram, the incenter would be the point where all the blue lines intersect, because the blue lines are the angle bisectors. Well, actually the blue lines are the perpendicular bisectors and the red lines are the angle bisectors. Now, when we use the term inscribed in, we're talking about images that are drawn inside of another image. So, for example, if we would draw a circle inside of this triangle, we could say that the center of the circle is inscribed in the triangle. Now that we know these terms, we're going to go ahead and look at a theorem, Theorem 5-7. This theorem is called concurrency of angle bisectors theorem. The theorem states the bisectors of the angle of a triangle are concurrent at a point equidistant from the sides of the triangle. So angle bisectors AP, BP, and CP are concurrent at point P. So those angle bisectors all intersect at point P, which you can see at the center of the triangle. And because of this, PX, PY, and PZ are all equal to each other, and PX, PY, and PZ are actually the perpendicular bisectors also.